So this lesson is on Unit 2, Lesson 1, Powers and Exponent Laws. And by the end of this lesson, you will understand that powers with integral bases excluding the base of 0 and whole number exponents are represented by repeated multiplication. Integral means that your bases of all your powers will be integers, and the only number it can't be is equal to 0. So let's go on to the next one. So what you guys have to do is remember that when we're multiplying integers together, since our bases are no longer going to be only positive numbers, they're going to be negative numbers as well. We have to remember when we multiply integers together what those rules are. So when we multiply a positive integer and a positive integer, you will get a positive product. So your answer is positive. When you're multiplying a negative integer and a negative integer together, you're going to still get a positive product. And then when you multiply any negative integer and a positive integer together, you're going to get a negative product. So that's all a review of grade 8. So here we have some quick checks. So 6 times 7 is 42. A positive, because when there is no sign, you assume it's positive, times a negative is a negative product, according to this law. 10 times 2 is 20. A negative times a negative is a positive. Now, if you don't want to put the positive sign, you don't have to. 9 times 7 is 63. And then a negative times a positive is a negative. So now, what I had the class doing is a math lab. So when you're multiplying more than two integers together, so let's see what happens. So if you have a negative times a negative, you're going to get a positive, and 1 times 1 is 1. A negative times a negative is a positive. A positive times a negative is a negative. 1 times 1 times 1 is still 1. A negative times a negative is a positive. A positive times a negative is a negative. And a negative times a positive is a positive. And when I multiply all these ones together, I get 1. Now you can do these in your calculator, but I would prefer not to kind of use your head and just practicing that, getting them right off the top of your head. So negative 1 times negative 1 is positive 1. Positive 1 times negative 1 is negative 1. Negative 1 times negative 1 is positive 1. And positive 1 times negative 1 is negative 1. Okay? So again, if you do the rest, you're going to see a pattern. Okay. So notice how many integers here I multiplied together. I multiplied 2 negative integers together. Look here, I multiplied 3 negative integers together. Here I multiplied 4. Here 5. 6 and 7 negative integers together. So what I was hoping that when you guys were working together in your partners that you would come up with the following rules. So rule number 1, when multiplying 2, 4, 6, 8, or an even number of negative integers together, you will get a positive product. Okay. When you multiply 3, 5, 7, or an odd number of negative integers together, the product will be a negative number. Okay, so that's what I was hoping that you would get out of this. So if I multiply 2 negative numbers together, and it doesn't matter about the positives, it all depends on how many negative numbers are in that multiplication statement. So if you have 2 negative integers, you're going to get a positive product. If you got 13 negative integers, you're going to get a negative product. It all depends on the number of negative integers. If it's even, it's positive, and if there's an odd number, it's negative. So let's go on to the next one. So it's a quick check. So 3 times 4 is 12, and there is one negative, so it's negative. 10 times 2 is 20, times 4 is 80, and there's only one negative, so it would be a negative integer, or negative product, sorry. 5 times 1 is 5, times 6 is 30, and there's two negative integers, so your product's going to be positive. 7 times 4 is 28, and 28 times 3, 28 times 3, I believe it's 84. And I have three negative integers. It's an odd number of negative integers, so your product has to be negative. Okay, sorry about that. So here I have 8 times 2, which is 16, times 5, which is 80, times 1, which is 80. And you have three negative integers. Remember, the positive ones don't, it doesn't matter about the positive, it's how many negative integers you're multiplying together. So you have a negative 80. Okay? So now, what is a power? In grade 8, you learned that a power is used to show repeated multiplication. Remember, I don't want to have to write 2 times 2 times 2 times 2 times 2. It takes way too long, so we're lazy. So we have a symbol. And so when I go 2 to the power of 5, that whole thing right here is power. This whole thing, when I have a base, which is what is multiplied together, and the exponent tells me how many times. So 1, 2, 3, 4, 5. So since I have 5 factors with a base of 2, that whole thing can be called power. Okay? Now there's a whole bunch of different ways you can read power. So when you have 2, just the number 2, it's actually 2 to the power of 1. Like, so if you see an exponent, or if there is no exponent, you assume that it's 1. So it would be 2 to the power of 1 or 2 to the first power. There's two different ways you can read that. If you have 2 times 2, two ways you can read that as a power is 2 squared, which we did in lesson 1, or 2 to the power of 2. If you have 3 factors of 2, 2 times 2 times 2, you have 2 to the power of 3, or 2 cubed. If you have 4 factors of 2, there's only one way you can read that, and that's 2 to the power of 4. 5 factors of 2 would be 2 to the power of 5. 6 factors of 2 would be 2 to the power of 6. But there are special ways we can, like 2 squared and 2 to the power of 2, they're used so common, so I guess they just give it's a special name for it. So just be aware of both. So here we have repeated multiplication. So this is a base of 2, and it tells me I multiply it 3 times. I have 3 factors of 2. Standard form is just a fancy way of saying the answer. So 2 times 2 times 2 is 8. 6 squared is 6 times 6. And then in standard form, it's just the answer, so 36. 3 to the power of 4 is 3 times 3 times 3 times 3. And you get 81. And then you get 8 squared, which is, 8 times 8 as repeated multiplication. You get 64. And 7 cubed is 7 times 7 times 7, 3 times. And you get, not 343, 49 times 7. I might have to do that one in my head. Holy cow. 1 second here. 7 times 7 times 7. Okay, why am I getting this wrong? No. 49 times 7. 343. I was right. Sometimes I second guess myself. Okay. So again, standard form is just the answer. So if it says write this power in standard form, you know you just write the answer. If it asks for a repeated multiplication form, then you know what you need to do. Okay, so now this is extremely confusing, so I'm going to go through this really slowly. When you evaluate an expression involving the negative signs, remember I said that that base can be both a positive number and a negative number. It cannot be 0. So now the negative throws in a whole bunch of crazy like trickiness. So identify the base and put it in repeated multiplication form and then evaluate. So notice that I have brackets around the -5. That tells me that I am taking -5 times -5 times -5 times -5. The negative is part of the base in the power. 4 is the exponent. Okay? So when you write it in standard form, you get 625. Because -5 times -5 times -5 times -5, there's 4 negative integers that are multiplying together. My product will be positive, and 5 times 5 times 5 times 5 is 625. Now, what happens if I don't have a negative around? Well, this is written that the negative is not part of the base. Okay, so it's saying that I have 5, whoops, I have to put the negative out in front. So no bracket tells us that 5 is the base of this power, not the negative. So if you wanted to do this, that's fine. Okay? Some students do that. So what they're saying is I'm going to take 5, multiply it by each other 4 times, and then I have to deal with that negative out in front. If you want to put a -1 in there, that's also fine. So it's huge, huge difference on whether the negative is in the brackets or if it's not in the brackets. Because if it's in the brackets, it's part of the base. If it's not in the brackets, it's not part of the base. Okay, so that's the caution is brackets are very important when dealing with powers. They determine what is the base to the exponent. Okay, so let's identify the base. So the base in this case is -3. And your answer will be 3 to the power of 4, 80. Oh my goodness gracious, why am I being so brain dead today? So 3 times is 81. And it would be positive because I have 4 of them. This would be saying -3 times -3 times -3 times -3. I have 4 of them, so it should be a positive product. Here, this is like saying -1 times 3 times 3 times 3 times 3. And I'm doing this purposely. See how I wrote it with the multiplication sign first, and now I'm using brackets? They mean the same thing. So in this case, only +3 is my base. And then since I have that negative out in front, I have to put a -1 in there. So my answer in this case is -81. In this one, I have -1. Oh, sorry, let me write this down. Base is -3 because that's what's in the brackets. But then I have that 1 out in front. So this is like saying -1 times -3 times -3 times -3 times -3. So in this case, it would be -81. So what I would do right now is I'd figure out how to use your calculator because every calculator is different. And if you don't know how to use your calculator, you need to come and see me. I can't answer those questions on a test. Part of the curriculum is you knowing which buttons to press. So in order to do a power, you'll be looking for this button. You'll be looking for this type of button. Sometimes I've seen this button. Sometimes I've seen like a little teepee. That means raise to, like raise it. What else have I seen? I think those are the main ones. But there are some other calculators that have different buttons. So you need to make sure that you are able to get these answers that I'm getting with your calculator. Making sure that you put brackets around every single calculator is different. You need to know how your calculator works before you go into that exam. So in this case, it's a quick check. Identify the base of each power, then evaluate. So the base is -1, so you'll get a -1. Again, make sure that you're getting the right answers with your calculator. The base is positive 10 because the negative is not in the bracket. So this would be negative 1,000. The base now is negative 7, so your answer is positive 49. Make sure you put the brackets around the base before you put it to the power of 2. Here, your base is negative 5, and we just did this something very similar. This is actually negative 625, because this is like saying negative 1 times negative 5 times negative 5 times negative 5 times negative 5. There's 5 integers we're multiplying together. So there's 5 negative integers we're multiplying together, so ours is negative and then 625. So that's it for this lesson. You are to do, so what you needed to know is that a power is a different way I can write repeated multiplication. Power is the whole thing. So if you have a base and an exponent, when you put it together, you have power. The way you read that is 2 to the power of 5. And then you have to make sure that you are very careful, because brackets tells you if the negative is part of the base or not part of the base. And then please make sure you know how to use your calculator before going into the exam. I won't be able to help you with those. Like, you can't ask me the question like, what button do I press, Mrs. Ketza? Because I won't be able to answer that. So your assigned work is 4B, 5C, 10, 13B, 13F, 14 on page 55, 56. If you're going for that honors average, you have to do 21 on page 57.